We're carrying on with the genotype phenotype. I think we haven't done this. So you've got a long winged and a short winged. Right. Capital L, it's homozygous dominant. That means only L is present. So the genotype is what genes, it's got phenotypes, what it's gonna look like. So they've said the allele for the long wings is dominant. So if you've got an L, big L, it's gonna be long winged. Here you've got hetero, it's mixed. Yeah, so it's a heterozygote. It's gonna be long winged. Why? Because you've got a long one in there. Right, you've got short winged. For it to be short winged, it's gonna be lowercase l, and it's gonna be homozygous recessive. So that contained the same types of dominant gene. This contains the same types of recessive genes. Right, what is a gene? A gene is a section of DNA. And what is DNA? Deoxyribonucleic acid. DNA. Right. A gene is made from 1000 base pairs. Shows the percentage of each base found in a gene. So you've got 29 adenine, guanine. So that is guanine. Ah, let's write that properly. Guanine. Calculate how many cytosine bases you would expect to find in this gene. So cytosine, you've got 21%. 21% are, what's 21% of 1,000? So it's 21% of times 1,000. Well, you'll have a calculator anyway. So it'll be 210. Is that right? Let's have a quick check. 210. We're expecting double that because you've also got 21%. So you just double that. So we're expecting it's made out of base pairs. Remember the thing is pairs. So you've got cytosine, you've got guanine, and at the end of guanine you've also got 210 cytosines. So you can end up with 420. 210 times is 420. It's only one marker. So they just want you to be aware. The key thing is, look, with this is to make sure that you read that it's a pair. So you're expecting 210 guanines, and attached to that will be 210 cytosines, and they've also said that there's 210 cytosines. Right, you've got a chicken, black chicken, white chicken, codominant. That means, so you've got a, oh, right, let's try something else. So you've got, this saying you've got, that codes for black, that codes for white feathers. And when you cross them, so if you end up with a C, W, C, B, either way around, you're going to end up with a, like a, I don't know what to call it, grey. We'll call it mixed, like this. Right. So we're expecting parent with all black feathers will have a CW, CW, oh, that's wise. C black, C black. White feathers will be CW, CW. Now, if you've got a mix, you're going to have CW, C black, and it can be in any order. Two of the offspring with a mixture of black and white feathers are made. So you've got C, W, C black from one parent, and C, W, and C black from another parent. So you're going to end up with CW, CW. Them two will become CW, C black. These two will become CW, C black. And this will become C black, C black. So if you look here, they're all white, they're all black. And these two here are going to be grey or black and white. What's the, oh, probability, I didn't answer that. Two offspring, mixture of black and white, like we've done there. What's the probability that of also black and white? So that's them two. So there's a 50% chance. Okay, Marfan syndrome is a rare genetic condition of the body's connective tissues. It can result in a person being tall, with abnormally long and slender limbs, fingers, and toes. This may also affect the heart and eyes. Children with the condition usually inherit from one of their parents. It is caused by the dominant allele M, not the recessive allele M. A homozygous recessive, right? So that means homozygous is the same and it's recessive, so it'll be two small M's. So this has come from the male, right? And this is from the female, so it's from a heterozygote with a heterozygote female. So capital M and lowercase m. Because they've said hetero, it means it's got both in. This has got M, big M, and small m. Right, use a genetic diagram to show the parental phenotypes. So what we have here is the parents will have M, M, and M, M. The gametes will be little m and big M and small m. The offspring will be big M, little m, big M, little m, little m, little m, little m, little m. Right. So the offspring genotypes will be these four that we had up here in this table. Let's push that up. So it'll be, you're going to get either big M, small m, or two little m's. Now, if you've got one of these big ones, you have the condition. Or you could have just put condition and then not no Marfan, or you can say it is unaffected. Right. A person who wanted to find out if he had Marfan syndrome, he asked his doctor for advice. Used information about the symptoms of Marfan to explain why it's difficult for a doctor. Right. Because look, have you may have just say for example you may have certain symptoms, for example a heart problem, but it may not be related. There might be other causes for the heart condition, not this Marfan, right? Also, you may not have obvious symptoms. You may have oh my god, I just read that. Symptoms. You may not have obvious symptoms and still have the condition. Or on the other side, you may have long fingers, for example, but you might not have the condition. It might just be a genetic. You've always had long fingers, your parents have. So what the doctor could do, it's always good to look at family history to see whether it runs in the family. Look at family history. You can do a genetic test, and you can to make sure what you do is you look for combinations of those symptoms. Combination of symptoms. Symptoms. Right. Many genetic disorders are caused by recessive rather than a dominant allele. Explain how examining family pedigree, as in the history, would enable you to tell if a condition was caused by recessive. Right. You could have a condition in offspring, in kids, but not parents. The condition may even skip generations, and you may be a carrier of the gene, but not have the condition. So it could be recessive. Okay, we've got a border collie. They suffer from an eye defect called collie eye anomaly, CAE. The dominant allele D produces good vision, but the recessive allele d produces poor vision. So this is homozygous dominant. So the white one does not carry. They do not carry the condition. These lot definitely do carry it. This is a carrier but does not have the condition. A carrier does not have the condition. All the offspring from cross R have good vision. Give the letters of other crosses where all offspring have good vision. So good vision, good vision, good vision, good vision, good vision. Basically, if you've got one white, you've got good vision. And so it's T and U. T and U. Okay. Give the phenotype of each parent used in. Right. Phenotype of parent used in cross P. Of each parent. Right. Okay. Because they've both got the recessive gene. So they've both got DD, so you're going to end up with poor vision. Because it's recessive, you need both the little p's to have the condition. Because of this here, because it's recessive. Which cross has a 50-50 chance of producing offspring with good vision? So let's have a look at that. So look, this has got good vision, good vision, good vision. That's not 50%. Good vision, bad vision. So it's S. Right, we have to come back up. Let's see. Right, give the genotype of each produced with cross T. Right, okay. We can see cross T here. Right, of each of the, so the first one, oh right, okay. So it's what do they call it? D, capital D for, so any white one is going to be a capital D. So that's what we're looking for. Yeah, so it'll be capital D, capital D, lowercase d. That is it. They're all of them are that. You'd have to write it 4 times. So it's a heterozygote. It's got one of each. Right. So we're looking at name the crosses between dogs. The crosses between dogs are examples of sexual reproduction. Name the gametes produced by males in sexual reproduction. So males produce sperm, females produce egg, or you can say ova or ovum. Give the terms used to describe diffusion of fusion. It's called fertilization. 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 There you go. Which organ do the offspring develop? Okay, that's in the uterus. We also call it the womb. Right. We've got crab disease is inherited, which affects the structure and function of the motor neurons. Remember, those are nerves. Is caused by a recessive allele. So if D is dominant, recessive will be. Capital D is dominant, lowercase d will be recessive. Yeah. Draw genetic genotype of these parents and their gametes if possible. So 2 parents are heterozygous for crab. Hetero means that they've got a mix. So if you look at mum, for example, it will be big D, small d. This here makes it hetero. So you've got dad as well. It's big D, small d. Right, you've got big D, big D, big D, small d, big D, D, and D, D. So if you look, because it's caused by the recessive allele, the only person that's going to get the disease is this person. So if your parents are heterozygote, there is 1 out of 4, which is 25% chance of you getting the disease. Okay, that's right. So this is a bit tricky. Look, producing a male child with crab disease. So you've got a 1/4 chance of having a crab and disease, and then you've got 1/2 a chance of being a male. So together you end up with 1/8 chance, 1/8 probability. So this is important, this, right? The chance of being a male is a half. The chance of getting a crab is 1/4. And then you multiply those to get 1/8. There you go. This is a math question. So the probability is that. So it's probability. No, 1 times 733. Right? And that should give 7.3 recurring, or 7.33, sorry, 7.3. So you can say 7, you're gonna have 7 children born with crab disease. Right, what did we say dominant allele was? We said it is an allele that is always expressed in a heterozygote. It's a dominant allele is always expressed in a heterozygote. Okay. The symptoms of Mercado Joseph disease do not become until okay. So the symptoms do not become obvious. So if you're not aware that you're a carrier, you're not going to test for it. Right. Suggests why late development of symptoms makes it difficult to reduce. So remember, people have children in their like 20s and 30s. So people will have already will have already had kids or children, right, before symptoms, doing that again, before symptoms appear. Before symptoms appear, so have already passed on their alleles to the offspring. Okay, Geno, gametes, right. Same structure. So we've done this before. So you have a man who is heterozygote for this condition has a child with a woman who is homozygote recessive. So we're saying D from dad and recessive D from mum. So we're going to end up with a big D, a small d from dad, and only a small type D from mum. Right, so when these breed, when they have kids, that's dad and that is mum. So when D gives you D gives you D gives you D gives you D. So you're going to end up, it's recessive. You get the condition if you've got these two small d's because it's recessive. So genotypes, it's D, and whatever, D. And the phenotypes, how does it show itself? How does it show itself? It's going to be, there's, you're going to say this has a disease. So it shows the gametes produce. Right, let's go back. It's caused, the condition is caused by the dominant allele. Right, okay. So we're saying you're going to end up with dominant. Right, let's just, the condition is caused by a dominant allele, not recessive allele. So that's gonna show disease, and this is gonna show dominant. No. So the way I see it is that's gonna have no disease, and this will have no. Okay, it's dominant. So the disease, if you've got big D, you have the disease. Right, I got my head around it. And this, because they're too small disease and it's a recessive, right? They're both recessive. You're gonna end up with no disease. Right, what is mutation? I think we did this earlier. Mutation is the random change in DNA. Looking for the word random and change. Right, okay. That was a toughie. It's getting your head around this. It's this here. Caused by the dominant gene or allele. So big D gives you the disease. Big D is there. Big D is there. So this, if you got this, you're gonna end up with a disease. If you've got this, you're not gonna. Right, we'll call it quits there.